Hi, in this demo we're going to talk a little bit more about physics bodies and some of the other things you can do. So first of all, in our create scene of our make scene, we've just set the gravity to 0 because we're going to apply forces to these physics bodies, or actually just initial velocities, and allow things to just happen according to the laws of physics as modeled by SpriteKit. So the next thing I've done is I've created a collision edge boundary. Now an edge boundary is different than a physics body that you create, say, with a circle or a solid physics body that we've looked at before. An edge boundary is simply an infinitely thin line that a body will collide with. But an edge boundary, unlike a physics body, a solid physics body, has no mass and therefore won't really participate on its own in the interactions with any other physics body. All I've done here is I've made a body with the edge loop from a rectangle and used the frame of the scene. And what that will do is draw an infinitely thin collision boundary around the edges of our scene. The next thing I've done is I've added smiley face nodes. I've added, in this case, actually 10. We can go back to 5. I was just testing. But I'm going to make them all the same size. I've defined a new method called make sprite with image, position, and velocity. So let's go ahead and look at that. I set up a new sprite node, sprite, that I'm going to be returning, and then I init with the image named and then the image that I pass in. Of course, all I'm doing here is passing in the smiley image here, smiley.ping. And then I've set up a physics body on that with a circular physics body. And then I've applied a velocity, and this, remember, is an initial velocity. The physics simulation will change this velocity in response to any collisions that happen. And then I've set the initial sprite position to whatever I pass in for position and returned the sprite. So once I have my smiley node, and what I'm doing here is as I count through from 1 to 5, I'm kind of very simplistically just applying a different position and velocity to each of these sprite nodes, depending on the value of I. So we could really do this with random numbers. We could do it this way. It really doesn't matter for purposes of this demo. I set the size of each object to smiley size, and then I apply a friction. In this case, I'm going to use 0 friction first, linear damping of 0, angular damping of 0. So really what I've got here is kind of a zero gravity environment in a vacuum. So there is no friction, linear damping, angular damping, and the restitution, the bounciness of each of these nodes is set to 1. And then I've added each node as I go through the loop. So what do we get from this? Well, remember, we have an initial velocity for each object. So the objects will begin moving, and then, or the nodes will begin moving, and then according to the physics simulation, they'll collide, and velocities will be changed as they collide, and so forth. So let's go ahead and look at this simulation. So here we go. First of all, they all start off with a different velocity, but as they collide, we notice that their direction, their velocity vector, in other words, is changing. There is no friction, and they're all what we might say perfectly bouncy, and so we get different velocities as we go through. Now, one thing that they're not doing is, because there's no friction, when two objects collide, they're not imparting any kind of angular rotation. So if we apply friction, and all we're going to do is apply a very small amount of friction, watch the change that happens now. Because they collide with friction, they begin rotating. And of course, as they, depending on the collision vector, they'll rotate more or less, depending on the speed at which they collide and so forth. And we see that the edge boundaries are working. And there we go. Now, if we apply, let's say, a very small force of gravity in the y direction. It should be in the negative direction because, again, y increases upward. So let's just say we apply a very small gravity vector in the negative y direction, like this, and now they will tend to fall to the bottom. But again, it's sort of a microgravity situation. As those speeds, as the velocity slows down in the y direction, they'll end up eventually bouncing off the bottom. And so we'll end up with a simulation in which all of the smiley faces will end up at rest on the bottom of the screen eventually. Of course, we can make that happen sooner by applying a higher force of gravity in the negative y direction. So let's do that. And now they're all kind of falling. They lose energy because they're being pulled by the force of gravity. So our physics simulation is working pretty well here. Of course, we can add more sprites. We could say, let's try maybe 8 and run that again. And now they'll all tend toward the bottom. We can see that as they head upward, they follow a path that leads them toward the bottom. The more energy they have, the higher up they'll bounce. But we see that all these paths are becoming more and more curved due to the force of gravity that is pulling downward. There's nothing that says gravity has to pull downward. Gravity could indeed pull upward. So, for instance, if we did this and then made our, let's say, even more, so it's even more obvious, then things will actually gravitate toward the top of the screen. So that's really about it. Physics bodies can collide in this way. And so the very last demo, the next demo we're going to have on SpriteKit, is how do we handle when the physics bodies collide? What steps do we take to make something happen when these bodies will collide? Thank you very much.